Good morning. I'm here to illustrate a fundamental digital circuit known as the arithmetic logic unit. So first of all, these are my gates. These are my gates. We have NOT gates, we have AND gates, we have OR gates, we have NAND gates, SOR gates. So let's start. I'll start with the AND gates. So bring the AND gate here. Then I'll change the number of inputs into 2. Then I'll bring my OR gate. I'll also change it into 2. I'll bring my SOR gate. I'll bring my NOR gate. Now I'll need a pin. I'll need a pin here. One pin here. Another pin here. I'll need my output button. I'll call it results. So I'll connect this to this. Now I'll connect each. I need to bring the add or subtract. So I'll go to arithmetic here. So I'll bring the adder. I need to bring the adder here. Let me bring it down small. So I need to connect this first pin to the first line. Then I will transfer it to the other first pin. Then I'll connect the first pin of the SOR gate and the first pin of the NOR gate, and I'll connect the second line to the second other pin. Then I'll connect each second pin like this. So I will change this one from medium to narrow. Yeah, I'll change it from medium to narrow. Now change this data bit to 1. So I need to connect the wires again. So I'll connect this one to this. I'll connect the first AND gate to this, and I'll extend it to the first adder, the first pin of the first adder. I'll change this one. I'll change the data bit to 1. Then I connect. So I'll connect each of first pin of the gate to the wire. Now connect the second one to the second one also. So I'll connect the second gate. Like this. So I'll name my first I will need multiplexer. I'll go to pleasure and I'll choose multiplexer. Now choose multiplexer. I will choose this one to top right. I'll choose this one to 3. Select bytes. So I'll just place it somewhere here. And I will include the enable. I need to disable it. No, I need to disable it. I'll bring the multiplexer in the middle here. So I need to get rid of this. I'll connect this one to the first one. So I'll connect the other to the multiplexer. So it will be 5 inputs here. It will be 5 inputs here. And I'll connect the result. I need to bring another pin here for it to connect. I'll change it to south. So I'll change this one. I will need another pin here to connect to the upper adder. So I'll place it somewhere here. So I'll connect it through this line. Like this. So I'll name it CE. So I've connected this one to the CE. I need to connect another pin to the C out. Then I'll name it C out. So I need another pin here, another gate, no gate. I'll just place it here. Then I'll cut this line. Then I connect this one to this. I'll need another pin also here. I'll bring it closer to this one. I'll name it sub. This is the subtraction. So now connect it to a second NOR gate. Like this. So if I turn this one on, so it will be 110. Here it will be 1110. If I turn this one 00 0001, this one 0001. So I'll connect it to the multiplexer. I've connected it to the multiplexer. You need another pin here. This one is the output. You need another output here. I'll bring it closer to this pin over here. So I'll connect this one. Connect it to this one. Then I'll name it set. Let's test it. These are 1001. As you can see, you can read from here. Everything is working. Everything is working here. Now let me add the decoder. I'm going to add the decoder here. Everything is working perfectly here. Now let me add the decoder. Let me try the decoder and see. So I'll get my decoder. This is decoder. I'll use the LED radar. use 4 lead. Combine it here. We need one output. Take it down here. Then I'll try and connect this to this. I'm just trying to see if it's working. The pin. So we are done. Now let's test it. This the seeing, the subtractor. We can add another key to make it 3. Then I'll name it C. This 110. On this, here 1. If you on this, here 1. If you on this, here 1. So this is a little explanation about this. So the status decoder, it plays a vital role by effectively decoding the numerical results and other internal signal like the cout into a set of distinct status flag or condition codes. Yeah. So this is the decoder, this is the scene, the subtractor, and this is the cout and the set. So this is the multiplexer. So these are the inputs. We have input A and B, it accepts binary data. Input A, B, C accept binary data along with the control signals such as the sub, and the scene and the operation execution. The central part of the circuit houses the logic for performing both arithmetic calculations like the addition. There is the addition and subtraction, aided by the XOR gate and bitwise logical operations. Result selection. A result selection. A multiplexer acts as a selector, directing the output of either the arithmetic unit or the logic unit to the main results output based on the specific operation being performed. The output and status beyond the primary results. So this is it. Thank you.